Okay, let's restart with the sample test number 8. Number 8, you have to find the derivative of the function f of t is arctan sine hyperbolic t. So, what is the derivative of arctan? Well, derivative of arctan, isn't that 1 over x squared? Well, this is your x now, so this is going to be 1 plus sine hyperbolic t squared. But then by chain rule, it's not x, therefore you're gonna have to take derivative of sine hyperbolic t. What's the derivative of sine hyperbolic of t? That's right, cosine hyperbolic of t. Okay, so you can tell me, do we stop here? Well, no, because identity 1 plus sine hyperbolic square t is cosine hyperbolic t squared. Right? So this becomes 1 over cosine hyperbolic of t, which is secant hyperbolic of t. Okay? And we can stop right there. Alright, move on to number 9. Find the indefinite integral of x cosecant hyperbolic square x squared over 2 dx. Now, you gotta be careful here. Make sure that you understand that this is the angle measure of x over 2. X over 2 is not just multiplied to cosine square hyperbolic square. Okay? Alright, so you guessed it, u substitution. So what if I let u be x squared over 2? What would my du be? Well, du will be 2x over 2, or I could write, well, let me go ahead and write this. So 2 and 2 cancel out, so isn't that just x dx? Okay. So do I have x dx? Yeah, I have it sitting right here. So now my u substitution will be complete. So I can go ahead and write x dx together, cosecant hyperbolic square x squared over 2. So I can just write cosecant hyperbolic square u, because that was my u, du. Integration of cosecant hyperbolic square u is negative cotangent hyperbolic u, is that right? You can check. And plus c, because it's indefinite. And then I can go ahead and put in my u, back substitute x squared over 2, and I'm done. These are short problems, and you should not have any problems with those. These are the ones that you need to do first, get those points, right? Let me get to the next one. It's number 10. Tangent hyperbolic inverse of sine of 2x. Okay. So tangent hyperbolic inverse of sine 2x. And again, we want to take derivative of this. So y prime, what is the derivative of tangent hyperbolic inverse? Well, that is nothing but 1 over 1 minus u squared. So this is going to be sine 2x. Make sure I'm copying that right. Yeah, sine 2x squared But then by chain rule, I'm going to take derivative of that. What is the derivative of sine of 2x? That's right. It is 2 cosine 2x by chain rule. Okay. So I can go ahead and write this. Well, identity helps a lot here. 1 minus sine squared 2x is same as cosine squared 2x. Okay. So then one of the cosine 2x cancels out, so I have 2 over cosine 2x, which is same as 1 over cosine is secant, correct? Yeah. Secant. Alright. Any questions? Well, you can ask me questions, sorry. Right, I will go to next page. This is page number 5. So I finished up to 10. Now I'm gonna go to page number 6 and go to number 11. Okay. Verify the solution of differential equation problem from 6.1. And I actually did that one in class. 11 and 12. The one that I didn't do in class is 13 and 15 and 16. So how about I just cut it short and do 13, 15 and 16 since I did the other ones in class. Okay, so I'm gonna move on to 13. Fast forward. We have dy of dx equals x times square root of x minus 6. So we are trying to find the general solution, meaning we're going to solve for y. Is this separable? If it's separable, we take the y's with the dy's and x with the dx's. And this is a problem from 6.1 definitely. Okay. So let me get to the problem in the book. Yeah, it's the problem from 6.1. Okay. Alright, so let's go ahead and do this one. Okay. So I can separate my dy. Alright, so where can we start here in this one? Well, this one, I'm going to integrate both sides. Integration of dy is y. Integration of this one is not going to be straightforward. Let's start here. Let u be that. Then what would you call u square? If u is square root of x minus 6, then can I write u square is x minus 6 because I'm squaring both sides? Oh, sorry, my board moved here. I keep looking at the camera here. Okay, so now if this is gonna be u, I have to worry about that x. So I gotta solve for that x in terms of u. If I solve for x in terms of u, can I not write this? Now if this is my x, what is my dx? Isn't that 2u du? This is one of those cases of u substitution where you cannot do anything here. You just have to make everything in terms of u. So what we did here is made x in terms of u, made that u, and also found dx in terms of du. Okay? Then we just plug it all in and then just integrate. So we're working on this one. So x is u squared plus 6. This is u. Dx is 2u du. So let's see what we have. U times u is u squared. So I have 2u squared times u squared plus 6 du, which is same as 2u to the 4 plus 12u squared. This is much nicer than what we had before anyways. So now we can go ahead and separate and integrate. So general power rule, this is actually u to the power of 5, kind of wrote kind of close. And now we can go ahead and put back whatever u was, so we're going to back substitute here. So this is 2/5. Remember, this is all equal to 1 of this to the 5th power. So I will write it as x minus 6 square root is half power. So this is 5/2 power plus 12 divided by 3 is 4 u cubed. So I will write x minus 6 to the half times 3 or 3 halves plus c. Now you can essentially stop right there, but we can also factor out. So 5/2 and 3/2 power we can factor out. What do you think we can factor out? Okay, how about we factor out 2/5 from each, and x minus 6 to the 3/2 power. So let's see what's left. So basically I'm dividing this one by this. If you took 3/2 out of 5/2, what is left? Well, only 1 is left, because you have 5/2 minus 3/2, 2 over 2 or 1, so you have x minus 6 left from the first term. Now you took 2/5 out there, so what's left on the inside? Well, all of that is gone. How can I take out 2/5 and still have a 4? Well, that's plus 10. Let's see. So just a little factoring here. Minus 6 plus 10 is plus 1. And now this is looking better already. Okay. Alright, keep it there for a few minutes or a few seconds. And then we're gonna move to 15 from 16.